I thank you all for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We will now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of June 2023. The problem is from the section Partial Differential Equations and it is related to the solution of the one-dimensional wave equation. This question is from the part B, which is a multiple choice question. It carries 3 marks. The question ID is 704044. This question is suitable for all these examinations. Right. The given question is let u of x comma t, u is a function of x comma t, be the solution of utt minus u suffix xx is equal to 0. That is dou square u by dou t square minus dou square u by dou x square is equal to 0. In other words, del u square by del u t square minus del square u by del t square minus del square u by del x square is equal to 0, where 0 less than x less than 2, t greater than 0. Given u at 0 comma t is equal to 0 is equal to u at 2 comma t for all t greater than 0. And u at x comma 0 is sin pi x plus 2 sin 2 pi x, 0 less than or equal to x less than or equal to 2. ut, that is the partial derivative of u with respect to t at x comma 0 is 0, 0 less than or equal to x less than or equal to 2. Which of the following is true? We are given 4 options. Option 1, u at 1 comma 1 is minus 1. Option 2, u at 1 by 2 comma 1 is 0. Option 3, u at 1 by 2 comma 2 is 1. Option 4, the partial derivative of u with respect to t at 1 by 2 comma 1 by 2 is equal to 5. Right. Let's now discuss the solution of the problem in detail. So we are given a second order partial differential equation, which is a one-dimensional heat equation, wave equation, right? Given u function of x comma t is the solution of utt minus uxx is equal to 0, which is a one-dimensional wave equation, 0 less than x less than 2, t greater than 0. And under these conditions. So these are the first one are boundary conditions, and the next two are initial conditions, right? And to solve such problems, you have to remember the general solution. The solution under these conditions for the general one-dimensional wave equation that I will explain to you. I am sure that you have to remember. There is no way you cannot solve this. It takes long time in the examination hall. So you have to remember. So first we talk about the solution of one-dimensional wave equation utt is equal to c square uxx, where 0 less than x less than L, t greater than 0. That's the one-dimensional wave equation. And this is a general one. And in our case, C is 1. C is 1. With boundary conditions, u at 0 comma t is equal to 0 is equal to u at L comma t for all t greater than 0. And the initial conditions are u at x comma 0 is equal to f of x, and u partial derivative with respect to t at x comma 0 is equal to 0. Right. So it is now the solution is under these conditions, the solutions is u x comma t is equal to sigma n is equal to 1 to infinity dn sin npx by L into cos npct by L, where dn's are given by 2 by L integral 0 to L f of x into sine of n pi x by L dx. These are all very familiar, but the only thing is you have to remember. Right. In our case, on comparison, we compare the general equation with the general condition, these conditions with our conditions, with our question. We get C is 1 and L is 2 and f of x is sin pi x plus 2 sin 2 pi x. Right. Therefore, with these conditions, C is equal to 1, L is equal to 2, f of x, with this given f of x, we get u of x comma t is equal to sigma n is equal to 1 to infinity dn sin npx by L, L is 2, into cos n pi ct by L, C is 1, L is 2, that is cos n pi t by 2. This is uxt. Right. We move to the next slide for the further discussion. Yes, that's what we have. Now, what we have not used so far is this condition u x comma 0 as sin pi x plus 2 sin 2 pi by pi x. So now take uxt, in that put t is equal to 0. So ux0 is equal to sigma n is equal to 1 to infinity dn into sine of n pi x by 2, and when t is 0, cos 0 is 1. So this is only this much. But it is given to be in our problem u x comma 0 is sin pi x plus 2 sin 2 pi x. Therefore, these two must be equal. Sigma n is equal to 1 to infinity dn sin n pi x by 2 is equal to sin pi x plus 2 sin 2 pi x. How do we get sin pi x in this expansion? If you take n is equal to 2, sine of 2 pi x by 2 to cancel, sin pi x you will get. So that means that is the coefficient of d1 is sin pi x. In a similar fashion, we see n is equal to 4, sin 4 pi x by 2, that is 2 pi x. So the n is 4 means d4 you have to consider. Therefore, the coefficient of d4 is sin 2 pi x. So d4 is 2, and d1 is 1. So this will imply d2 is 1, not d1, d2 is 1, and d4 is 2, and there are no other terms here, therefore the remaining dn's are all 0. Right. Now go back to our solution. Then uxt is equal to d2 sin pi x into cos pi t. That is, you substitute n is 2. So d2 sin pi x cos pi t plus d4 sin 2 pi x into cos 2 pi t. That is, n is 4 pi t by 2, that is 2 pi t. So that is the solution. So we are done. The problem is over. Now it's just only you take this and verify the conditions given in the options. Right. So d2 is 1 we have substituted, d4 is 2 we have substituted. Thus you got uxt is equal to sin pi x into cos pi t plus 2 sin 2 pi x into cos 2 pi t. Right. We go to the next slide for the options. Right. We have that solution with us. So call on option 1. U at 1 comma 1. That means put x is equal to 1, t is equal to 1 in this. Then u11 is equal to sin, x is 1 sin pi, t is 1 cos pi plus 2 sin 2 pi into cos 2 pi. Sin pi is 0, sin 2 pi is 0, therefore it's 0. But it is given minus 1. Therefore, option 1 is not true. Go to the second one. U at 1 by 2 comma 1 is 0. So substitute in this solution x is 1 by 2 and t is 1. Then you will get sin pi x pi by 2 cos pi t pi cos pi plus 2 sin 2 pi x 2 pi by 2 into cos 2 pi t is 1 cos 2 pi. Now here sin pi by 2 is 1, cos pi is minus 1. So 1 into minus 1 minus 1 and sin 2 pi by 2 is sin pi, it is 0. The second term is 0. You will get minus 1, but it is given 0. Therefore, option 2 is not true. Go to the option 3. U at 1 by 2 comma 2 is equal to 1. Substitute in the solution. X is equal to 1 by 2 and t is equal to 2. So if you substitute here, sin x is 1 by 2 sin pi by 2 into t is 2 cos 2 pi plus 2 sin 2 pi into x 2 pi by 2 into cos 2 pi into 2 cos 4 pi. Now in this, sin pi by 2 is 1, cos 2 pi cos 0 is 1, is 1, 1 into 1 1, and in the second term sin 2 pi by 2 is sin pi is 0. The second term becomes 0, it is equal to 1 and it is given to be 1. Therefore, option 3 is true. Go to the fourth option. The partial derivative of u with respect to t at 1 by 2 comma 1 by 2 is pi. So take this solution. Differentiate partially with respect to t. ut xt is equal to sin pi x into differential of cos pi t is minus sin pi t with respect to t pi. So minus pi sin pi x sin pi t plus 2 sin 2 pi x into differentiate with respect to t, that will be minus sin 2pt and multiplied by 2p, that is minus 2 pi into 2 sin 2 pi x sin 2 pi t. So substitute in this, x is equal to 1 by 2, t is equal to 1 by 2. Then you will get minus pi into sin of pi by 2 into sine of pi by 2. That is 1 into 1 into minus pi. Here you will get, it is when x is 1 by 2 sin 2 pi by 2, that is sin pi, this becomes 0. So second term becomes 0. The answer is minus pi, but it is given to be pi. Therefore, this option 4, is not true. Summarizing all the options, the answer to this question is option 3. That is the detailed discussion of the solution of a problem from the section partial differential equations, which is related to the solution of one-dimensional wave equation. And to answer such a kind of problems, you have to remember the general solution. So generally, with the given initial conditions and boundary conditions, what is the solution for such equations? You have to remember, right? If you remember, the things will be very easy. Otherwise, solving such a kind of an equation using separation of variables and applying all these conditions in the examination hall, it will take a long time and it is not feasible. And hence, you have to remember, there is no way when you are writing such a kind of a competitive examination, you have to remember several results and you have to remember some of the solutions also. That will be an asset for you. So, with these few words, I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we will meet once again for another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.